Right, I'm going to prove a couple of things about cosets. I'll just get C, which is any coset of G. And basically I'm going to show that cosets are distinct and that they're all the same. And we can deduce quite a lot from that. So, if I've got an element A of my group G, which is a member of C, I'm going to assert that that's true if and only if and only if AH equals C. So that's quite a powerful statement. So this is any coset at all. Just pick a random coset and then we find an element that's a member of it. And then I'm going to basically say that that coset is the coset generated by A, or the left coset of A. And of course all this stuff just works for the right cosets as well. Okay, so what I'm going to do is prove it in two. I'm going to prove it in two steps. Firstly, I'm going to prove if A is a member of C, then I'm going to deduce that AH equals C. And then I'm going to prove the next one, which is that if AH equals C, then I'm going to deduce that A is a member of C. Okay, so let's just try one first. Actually, I'm going to try two first. I think two might be a bit easier to prove. So I know that AH equals C. So of course, well, the identity is a member of H. So that tells me that AE is a member of C because I'm just choosing that member of H. And so that tells me that A is a member of C. QED. There we go. So that's number two done. Should have written these in the other way around, I guess. Okay. So now what's the other one left? I've got if A is a member of C, then I want to show that AH equals C. What's the terminology? This is just any old coset here. This element A is any member of group. A is any member of the group. Actually, it's more than a member of the group. It's a member of my coset C. Okay. Well, so what I want to do is to work out what the coset actually is. So if I've got A is a member of C, what that tells me is that, well, let's just say that the coset is BH, but I don't know what B is. B equals something, which I don't quite know yet. So what that tells me is that if A is in this coset, that I've just rewritten coset C as BH there. Alright? So what that says is that A is a member of BH. And so what that says is there exists little h in H with A equals BH. Okay? Now what am I trying to show here? I'm trying to show that the coset C is equal to AH. Okay, well what that tells me there is, that AH equals BHH, okay, which equals BHH, and now we use the fact that capital H is a subset of G, a subgroup of G. So that's just equal to BH, and that's what I wanted to show. Because look, I've said that this coset here is BH, but I didn't know what B was, and now I still don't really know what B is, or it doesn't matter what B is, but what I have done is shown that the cosets are the same. So let's just review what I've said here. This is the statement which I've just proved, which is that we've identified a coset, we found an element in that coset, and if I found an element in the coset, then that element multiplied on the right by group H is indeed that coset. Okay, so that's quite a powerful piece of information about cosets there. I've characterised a coset just by finding an element inside it. Okay, if I know what H is. I'm going to stop there.